Few things one can see in the sky is more striking than a fireball or bolide. Annual meteor showers occur. They are the dust trail, left over from comets, and each year Earth passes through the former path of a comet predictably, and thus one can go out and see them if you know the dates. But in the case of true fireballs, they tend strongly to be sporadic and often leave meteorites behind. Sometimes meteorite hunters find them, sometimes they don't, based on trying to reconstruct the path. But it's a good bet that over the course of one's life, you will see a particularly large meteor that very well may leave meteorites behind on the ground. I have seen quite a few, but I recently saw an impressive one just a few months ago in the central Midwest. It was a very markedly green fireball and was visible at about dusk. That was reported in Arkansas and Missouri that basically crossed most of the sky, and for me, actually crossed to the horizon. I have seen a number of fireballs of that type over the years, but this particular one, in addition to being bright green, was sparking, for lack of a better term. Almost to the point that I initially thought it to be some kind of weird firework, but then it just kept going, and many people across the two states saw it, and it made the news in social media. But it didn't stop there. In the subsequent months and ongoing now, an unusually large amount of fireballs started being reported worldwide. One recently in Ohio, in fact. Fireballs are nothing new, but they can be dangerous. A big enough one can form a crater and be very dangerous indeed, especially if you're a dinosaur. But most of the time, they might do damage from sonic booms, detonations, and so on. And occasionally, the meteorites can hit houses and go through roofs, or even damage cars. But damage remains rare for meteorites to any severe degree. They are simply a fact of living life on planet Earth. And to see a particularly interesting one, look up the Chelyabinsk meteorite fall from some years ago that did severe damage over Russia from its detonations and sonic boom. But most of the time, meteorite falls like this end up in the ocean, and no one or few will see it. But an interesting blip, so to speak, in fireballs is currently occurring. The American Meteor Society, which tracks reports of meteors and fireballs, is reporting an uptick of fireball events for the first quarter of 2026, enough that it seems to justify a scientific investigation as to why it's happening. The increase is huge, and is not statistically insignificant. This probably isn't a fluke. So about the AMS, they have had a reporting system in place since 2005 that became extensive around 2018. Their data from previous years shows about 1,100 to 1,400 reported events per year. For 2026, so far, it's already at 2,322 events. That's really high for this early in the year. One option is that more people are reporting events than in the past, but that doesn't really hold up here. Rather, the statistics of this show this to actually be a real effect, and these things are producing sonic booms. In the data for events where there were over 50 reports, sonic booms were heard by multiple witnesses in 33 out of 40 events. That's very high historically. And then comes March, and it gets weird. So on March 8th, there were 3,229 reports of a slowly moving fireball across Western Europe, with almost 200 people reporting some kind of sound. This one had recovered meteorites found, and while classification of the meteorites is not complete yet, they appear to be a type of meteorite called a diogenite, which is actually a rare type overall, and belongs to a group called the chondrites. These are meteorites that are more like melted volcanic rock than pristine aggregate remnants of the early solar system, and they are strongly linked either directly to the large asteroid Vesta, or some asteroid that may have been shattered to pieces long ago that was very much like Vesta. Then, on the 11th, there was another fireball visible in France and Spain. And on the 17th, there was the Ohio fireball that had several hundred reports. This was a large one. The energy released is estimated at 250 tons of TNT, and the recovered meteorites are eucrites, another type of a chondrite associated with Vesta, or an asteroid similar to it. These really are rare meteorites, and for two recovered falls to belong to the same rare family of meteorites within days of each other is highly unlikely. But it in fact happened. On the 21st, there was an anomaly. A fireball was visible in daylight that had almost 200 reports over Texas near Houston. An incomplete fragment, there are probably more meteorites out there to be found, slammed into a roof of a house and embedded in the floor. Analysis showed this to not be an chondrite, but a normal, at least for meteorites, common chondrite, which are more primitive rocks. This is not likely to be related to the other falls, but a random chance event. On the 23rd, 2 fireballs were seen by over 100 witnesses on the same day. The first was a vivid green fireball, much like what I saw, around San Diego, and another more east towards Las Vegas. Also in the state, 2 more were observed in Germany. The next day, there were fireballs over Michigan and Georgia. This is a lot. Meteorites or meteors from the same event in space, however, tend to cluster and come from the same general direction in the sky, called a radiant. Here there seems to be 2 statistical radiants, which means that these may be due to 2 separate events, breakups of asteroids basically in the past, that are now hitting Earth at the same time by chance. So what can be ruled out is the first question. The AMS says that increased reporting or smartphone proliferation is not likely here, because based on their data for previous years, there is an anomalous occurrence here. It also is not related to any known annual meteor showers. There can be sporadic increases associated with the position of the Earth, but this doesn't correlate to past years. It's also global, so there isn't a geographic or time bias here. But there may be problems with reporting involving the rapid proliferation of AI. Who knows what people that see a fireball ask a chatbot about it and how that affects the reporting. Only future reporting for the rest of the year and beyond will shed light on that. What is known, though, is that these are indeed normal solar system meteorites entering the atmosphere based on the recovered samples. But the question is, why so many lately? With the recovered meteorites, analysis is key, and it's not that far along yet. You can look at things like cosmic ray exposure and try to reconstruct if the independent meteorites are related to some past event that shattered an asteroid. What's important to note here, though, is that this does not indicate any kind of danger of a larger impact. Past a certain threshold, we will see anything dangerous long before it falls. But these small falls, we typically do not have the resolution to see, fireballs though they are. And they only pose local dangers like sonic booms, and do not present a major threat. It's just interesting in that there does seem to be an uptick. But something like this has happened before. This involves the infamous meteor crater in Arizona known officially as Barringer Crater. About 50,000 years ago, an enormous iron meteorite struck the ground and blew out the famous crater, littering the landscape with iron meteorite fragments, and even a coating of tiny metallic spherules where the iron had vaporized and condensed down, raining across the desert in the area. The story of where that meteorite originally came from is a complicated one, and sort of counterintuitive. It's thought that the meteorite, which the meteorites themselves are called Canyon Diablo after a nearby canyon, originally was from a relatively large asteroid that took a severe impact early in the history of the solar system. This impact caused melting and differentiation, meaning that the metals, mostly iron and nickel, settled at the bottom of the crater, and it potentially sank even further down. There, the metal cooled very slowly, allowing the nickel-iron to crystallize and form a Widmanstätten pattern. The coarser this pattern appears when sliced specimens are etched with acid, the slower the cooling process was. Above the metal, however, the stone silicates formed a cap, and that rock is very distinctive in its makeup. This type of meteorite is known as a Winonaite and is very rare, and chemically is directly linked to the same asteroid as the iron Canyon Diablo. Above the Winonaite layer would have been a breccia layer of normal asteroid debris, generally unaltered by the impact. At some point in the history of that asteroid, it was struck again by an impact, which blew both the Winonaites and the Canyon Diablo main mass off the asteroid. The 2 types of meteorites would then have wandered the solar system for several billion years, never to encounter each other again. But oddly, they actually did. So at some point after the crater-forming impact of the Canyon Diablo meteorite, a Winonaite from the same asteroid fell in Winona, Arizona in prehistoric times. This meteorite was recognized by the local indigenous people. They may have even seen it fall as something odd, and they buried it inside a pit inside of a pueblo for archaeologists to later find and recover. This meteorite is the namesake for the Winonaite meteorites. So by sheer chance, two meteorites from the same crater floor on an asteroid blown up billions of years ago that should never have encountered each other again managed to fall in the same state, Arizona, at different times, but close enough before enough time had passed to weather either one of them away. And the Winona meteorite was found only about 20 miles from the crater. Strange coincidence indeed. And now for a very rare moment. I stopped the presses on production of this video. It would have been out an hour earlier than it was, but a potential development of this story quite literally occurred an hour or so ago as Artemis II looped around the moon, and should have seen the moon in relative darkness. But it didn't. First, they noted unusually strong light from Earth reflecting off the lunar surface to the point that they could see features. But they also noticed something else. So during Apollo 17, astronaut Harrison Schmitt noted strange, mysterious flashes on the surface of the moon during the lunar night. These were not seen by any of the other Apollo missions, and while all missions noted flashes, they weren't on the moon, but rather cosmic rays hitting the retinas of the astronauts. But some were not that, and were indeed present on the surface of the moon. These same flashes were just seen by the Artemis II crew, looping around the moon. Last I heard, they noted 4 of them in a very short time. These flashes are believed to be meteorite impacts on the moon as they hit. But 4 in the space of an hour and a half is a lot, and that may be a product of this uptick in and of itself. Mission Control at NASA noted that amateur astronomers may have also seen and perhaps even photographed these flashes from Earth in the dark night area of the moon, so the story may well develop further. Stay tuned. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently shoring up my roof concerned about a meteorite fall. The bright side of that is that if your house does get hit by a meteorite, a fresh meteorite with a story like that is worth a fortune, typically far more than what the roof repair would cost. Indeed, a meteorite once plowed into a car, and not only did a meteorite dealer buy the rock, they also bought the damaged car for a large sum. Anyway, be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.